On quadratic functions. The standard form for a quadratic is f of x, which is y, is equal to ax squared plus bx plus c. The a, b, and c are real numbers. And a cannot equal 0. If a equals 0, we don't have a quadratic term. We don't need a linear term, we don't need a constant, but we do have to have a quadratic term, otherwise we don't have a quadratic equation. Now the coefficient of x, the a value, if that a value is positive, we have a happy smiling parabola. If the coefficient of the quadratic term is negative, we have an unhappy, an upside down parabola. So this might help you to remember what direction the parabola is going. If a is positive, the parabola is opening up. If a is negative, it's opening down. Okay, I want to start with the axis of symmetry, and that is x is equal to negative b over 2a, the axis of symmetry. So we have x is equal to, the b value is 8, so it's negative 8 over the a value is positive 2, 2 times 2. So we're getting negative 8 over 4, or the axis of symmetry is x is equal to negative 2. So what that means is when we go to the graph, this dotted line represents the line at which the parabola looks the same on either side. It's symmetric with respect to this line. It's called the axis of symmetry. Okay, next I want to get the zeros where the graph crosses the x-axis. So I'm going to change f of x to y. Y equals 2x squared plus 8x minus 10. In this problem I can factor out 2. X squared plus 4x minus 5. And then I factor the trinomial into the product of two binomials. So I have y is equal to 2, and then this factors into x and 5 and 1. I want the middle term to be a positive 4, so I make it a positive 5 and a negative 1, so that 5x and 1x gives me 4x in the middle, and a positive 5 times a negative 1 is negative 5. 2 does not have a variable with it, so I don't set that equal to 0. So I take the other two factors, x plus 5, and set it equal to 0, and x minus 1 equals 0. So x equals negative 5, x equals positive 1. And these are the zeros of the graph, where the graph crosses or touches the x-axis. Now you'll notice the axis of symmetry is at x equals negative 2. If I go 3 units to the right, that's where I get a point on the graph of positive 1. If I go 3 units to the left, I get a point of negative 5. It is symmetric on either side of the axis of symmetry. Now I want the vertex. So what I'm going to do is I'm going to take and substitute negative 2 in place of x. So I have f of negative 2 is equal to 2 times negative 2 squared plus 8 times negative 2 minus 10. Now you square negative 2 first. Negative 2 squared is 4 times 2 is 8. 8 times negative 2 is negative 16 minus 10. So 8 minus 16 is negative 8 and negative 10. And I'm getting a y value here, or f of negative 2 is equal to negative 18. That means that that is the vertex. The point negative 2 for x, negative 18 for y. Now on this graph, if I went further down here to where I had negative 18, then on the axis of symmetry, I'd have that point. Again, this is only a sketch. And then I would graph the parabola like this. So first I'm finding the axis of symmetry, then I'm getting the zeros, which is solving this equation and see where it touches or intersects the x-axis. Then I'm taking the x value from the axis of symmetry, substituting it in to the quadratic function, getting the y value, which then gives me the vertex. In this case, because the graph opens up, this is a minimum. So again, I'm going to start with the axis of symmetry. X is equal to negative b over 2a. So I have x is equal to, b value is 8. So I have negative 8 over the a value is negative 2. So that's 2 times negative 2. Negative 8 over negative 4 gives us an axis of symmetry of x is equal to positive 2. Now I want to take and find the zeros, and this equation is not factorable. Therefore, I need to use the quadratic formula. So the axis of symmetry, x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. B is 8, so I have negative 8 plus or minus the square root of 8 squared, or 64, minus 4 times a, which is negative 2, times c, which is negative 5, all over 2 times negative 2. So I have x is equal to negative 8 plus or minus the square root of 64. Now negative 4 times negative 2 times negative 5 is equal to negative 40 over negative 4. X is equal to negative 8 plus or minus the square root of 24 over negative 4. Let's break the radical down. I have x is equal to negative 8 plus or minus the square root of 4 times the square root of 6 over negative 4. I break it down into the product of two numbers where one of them is a perfect square. That's why I use the square root of 4 and the square root of 6. Now I have x is equal to negative 8 plus or minus the square root of 4 being 2 times the square root of 6 over negative 4. Now there's a triangle here, not looking at the radical, but looking at the negative 8, the 2 in front of the radical, and the negative 4 in the denominator. I'm looking for a number that divides into all three parts of that triangle. So I'm going to divide 2 into each part. 2 into negative 8. 2 into 2 is 1, so I just have the square root of 6. And 2 into negative 4 is negative 2. Because I have negative 4 and a negative 2, I can multiply numerator and denominator by negative 1. I can change any three signs in a fraction, the numerator, denominator, or the sign out in front of the fraction. Changing any two of the three doesn't change the value. So I'm going to change this to a positive 4. Now the plus or minus changes, but the plus changes to minus and the minus changes to plus, so it still is going to be plus or minus the square root of 6 over positive 2. Now I need to be able to graph that. I still need, that is the solution, the roots, the zeros. So where am I going to put that on the graph? Well, let's take a look at the square root of 6. Now, even without a calculator, the square root of 6 is between a perfect square of the square root of 4, which is 2, and the square root of 9, which is 3. So I know it's between those two, and I know it's roughly halfway between them. So I will try some values, 2.3, 2.4, 2.5, and square it and see which is closest to 6. And an approximation is 2.4. So if I take 4, I'm going to here, 4 plus or minus 2.4 over 2. So 4 plus 2.4 is 6.4 over 2, or x is equal to 3.2. That's approximately one solution. The other is 4 minus 2.4, or 1.6 divided by 2, so the other value is 8/10. So if I go from the y-axis, if I go over 3 and a little bit more, I get a point on the graph, and if I go a little bit less than 1, you see that they're evenly spaced. I still don't have a vertex. So the vertex is by substituting x equals 2 into the quadratic equation to get the y value for the vertex. So I have negative 2 times 2 squared plus 8 times 2 minus 5. Squaring 2 first, 2 squared is 4 times negative 2 is negative 8. 8 times 2 is 16 minus 5. A negative 8 and a positive 16 is 8, and 8 minus 5 is 3. So I'm getting a y value, which is equal to 3. That means the vertex is the point where x is equal to 2, y is equal to 3. And we know that if the coefficient of the quadratic term is negative, that the graph is going to be upside down and it's going to look like this. And because it's upside down, we know that this value is going to be a maximum. So we're going to write the equation of the quadratic given the vertex. In this case, I picked negative 3, 4, and the point, negative 4, 7. The vertex is hk, and the equation is f of x equals a times x minus h quantity squared plus k. So I'm going to substitute in for f of x, which is y, in for x, in for h, and in for k, which is solving for a, the coefficient of the quadratic term. So f of x is the same as y, so that's y is equal to 7. A we're solving for. The x value is negative 4. The h value is negative 3, so it's minus a negative 3, quantity squared, and the k value is 4. Negative and negative is a positive, so I'm getting 7 is equal to a, and a negative 4 plus 3 plus 4. And this is quantity squared. So I have negative 4 plus 3 is negative 1. Negative 1 squared is 1. And when I subtract 4, I get an a value of 3. Now I'm going to go back to f of x is equal to a times x minus h quantity squared plus k. This time I'm only substituting in for a, h, and k. So I have f of x is equal to the a value we just found of 3, the h value that we get from the vertex, which is a negative 3, and the k-value from the vertex, which is 4. So f of x is equal to 3 times the quantity, x plus 3 quantity squared, plus 4. Now I'd like to simplify that and put it in standard form. So I have f of x is equal to 3, and then I'm going to take x plus 3 and square it. And then add 4. F of x is equal to 3. Taking x plus 3 times x plus 3, the first terms of each, x times x is x squared. The outside product is 3x. The inside product is 3x, which gives you middle term of 6x, and 3 times 3 is 9. And still plus 4. Then I have f of x is equal to, distribute the 3x squared plus 18x plus 27, and again I still have the k-value of plus 4. So simplifying, I get f of x is equal to quadratic term of 3x squared, a linear term of 18x, and a constant term of 31.